Hi, everyone, and welcome to episode 5 of the Open Source Podcast. Today is Wednesday, February 21st, 2018. My name is Jeremy Hess, Community Manager at Cloudify. Today we have a great group of panelists with us to discuss the ONAP project and dive into some of its use cases. Mobile World Congress is right around the corner, and ONAP is, of course, one of the biggest talking points in the networking world right now for telcos. So with us today, we have Amir, Levy, and DeWayne Filppi from Cloudify, as well as some of the great product and architecture team from AT&T Tel Aviv, who have worked on eComp and ONAP from the early days. We have Rozin, Roy Ben Chai, and Michael Lando. So Amir, why don't you go ahead and start us off by introducing yourself?
Hi, Amir Levy. I'm from Cloudify, based in San Jose, California. I'm a technical market development director in Cloudify, working for the CTO, working the CTO office, and I'm responsible to the technical direction for Cloudify within ONAP. I sit in ONAP TSC, as well as the newly formed Linux Foundation Network Technical Advisory Committee.
Great, thanks. And DeWayne, why don't you go ahead and give us a short intro?
Hi, my name is DeWayne Filppi. I'm a senior architect in the CTO office at Cloudify. I'm a committer on the SO project in ONAP, contributor to the ARIA project, the Apache ARIA project, and I guess that's it.
Great, thanks. Okay, Eden, why don't you go ahead and introduce yourself as well?
Hey, Jeremy. Hey, guys. So I'm Eden Rozin. I lead the product group in Tel Aviv that's focused on what AT&T calls Domain 2.0 activities. It's also the cloud activities based on OpenStack and obviously eComp from the early days, from its prototype stage as a proprietary OSS framework of AT&T, and we did all the needy stuff in order to get it to ONAP. So you can consider me as an eComp veteran today.
That's great. Thanks for that. All right, Michael, why don't you go ahead and introduce yourself?
Okay, hi guys. My name is Michael Lando. I'm from the Tel Aviv AT&T team. My responsibilities in ONAP, I'm leading SDC as the project technical lead. In addition to that, I'm also responsible for the architecture overview of both SDC and VID in ONAP. My background is I've been working on SDC pretty much from day one. I've seen it grow from a small application during the last 3 years into what it is today.
Great, some real veterans. Okay, and Roy, why don't you go ahead and introduce yourself?
Hi, I'm Roy Benhai. I'm on Eden's product group, working on the ONAP developments that we're working on in Tel Aviv.
Okay, great. Thanks, everybody. All right, so let's go ahead and get started. And what I'm going to do is ask Amir to go ahead and give us a little bit of an introduction to the ONAP project, what it's all about, and what they're really trying to push forward here.
Sure. Thanks, Jeremy. So the telecom industry is standard-driven, and over the years, there have been multiple groups that have been formed to cover specific elements of the stack. There is notable contribution from IETF, IEEE, ETSI, MEF, and TM Forum. A lot of alphabet soup there. But the challenge is that it's not just an alphabet soup. It's also a fragmentation between those groups. And it's been very difficult, especially in a fast evolving software world, to consistently meet the demand that roles of standard are there, which is to ensure compatibility and interoperability. So within this void, this has been, in the software world, been led by de facto standard as a product and open source project. We're able to demonstrate compatibility and achieve quite an amazing productivity. So we've seen projects like OpenStack and containers and NoSQL really driving de facto standards that driven by adoption. The structure of them is more democratic as more developers can participate and contribute. It reduces the effect of political agendas from the way that projects are driven by the ability of individuals and companies to contribute real code. But that creates by itself its own fragmentation of too many open source projects. Each one of them is covering different parts. This where ONAP is such a significant contribution and advancement is that it's an orchestration platform designed as an open source project. It's policy driven. It looks at automation of physical and virtual network functions and enables software, network, and IT as a cloud provider for developers or for automating services and support lifecycle management. ONAP is actually a merger of a previous open source project led by China Mobile called OpenO. O stands for orchestration. This was being governed by the Linux Foundation. Later, AT&T were willing to contribute a very significant open source contribution coming from their eComp as an open eComp, and those open eComp was merged with OpenO, and that created ONAP, which is today the largest by both code base, contribution, active participants, and use case open source project leading the orchestration work. So the ONAP is defining blueprints for use cases, and the user community is pursuing testing those blueprints and providing both open source and commercial elements that integrate into the ONAP solution, by that providing this de facto standard or standard by code that is driving the overall NFV industry. By that, maybe Michael, you can cover in a little bit more details the ONAP architecture.
Yeah, thank you, Amir. Okay, so let's deep dive into it. So basically, it's important first to differentiate the ONAP architecture into two separate parts. The definition is we have the design time and we have the runtime. The design time hosts the SDC and VNF SDK. Both of these applications are meant to receive VNF's virtual network functions from different vendors, onboard them into SDC, and then model them into services. These services are basically templates that can be distributed to runtime components for orchestration. So basically, in design time, you design. You have different modeling capabilities. You can design VFs, services, workflows, the one that were mentioned, the BPMN. You can define policies. You can define many different components. All of these components are packaged together into a package called Caesar. This package is later distributed to the runtime components for orchestration. In ONAP, in the runtime components, you can find a lot of different components, each one responsible for a different part of the process. You will find SO, the service orchestrator, responsible for orchestration. You will find NDI, which is responsible for the inventory, understanding what is deployed where and where we can deploy it. You can find the DCIE, which is the main platform for monitoring and collecting the different notifications. You will find the policy, which is responsible for activating policies based on different pre-configured definitions. You will find the SDNC, which is the networking controller. You will find APSI, which is responsible for the different configurations. It's important to understand the scale of ONAP. ONAP is a huge platform that's been developed which came as a merger, as said before, between the eComp from AT&T and OpenO. This was a successful merger because in the first release, we were already working together. We had different components coming from different open source communities, and we managed to stitch them together in such a way that even in release 1, we already had at least one working use case that went through the different components. This is the greatness of ONAP and what we managed to achieve up until now. As we go forward in ONAP, we will have a lot of different capabilities being added to the ecosystem. The capabilities range from capabilities regarding modeling, allow us to model different new items or different new capabilities. You will have also runtime capabilities that are added. As an example, in release 2, we'll have OOF, which is responsible for providing different homing policies for the VNFs that are being orchestrated, and much, much more. In the end, the system will grow to new heights as we progress forward.
Thanks, Michael, for the breakdown. Very interesting stuff. And you mentioned a bit about modeling and stuff like that. So I think it will be a good time to segue into a little bit about how the modeling in ONAP works. And we have DeWayne with us, who, as he mentioned earlier, is part of the SO project, has been a committer to the SO project. And DeWayne, would you give us a little bit of a breakdown about, or a little explanation as to, where the different modeling types are involved here, specifically Tosca, obviously, and BPMN?
Yeah, sure. So my basic focus in the SO project is to incorporate Tosca a little more deeply into an otherwise workflow dominated design process. The current effort that I'm involved in is essentially baking in a Tosca orchestrator directly into the SO code base. This is to not really to act as an alternate path per se to the what you would call the nominal BPMN workflows that are constituting ONAP today, but to act as a different option for modeling. There's a cooperation that occurs. Like we had just recently mentioned the introduction of the OOF, or the optimization framework. There's also the SDNC, which deals with allocating network resources. Those things are preconditions even of a Tosca orchestration. They essentially produce outputs that can be input into a full-blown Tosca orchestration, and that's as far as the integration of Tosca. That's kind of where we stand. We're functioning right now at a VNF infrastructure level, and looking to move Tosca a little higher up the stack into service orchestration.
Great. All right. Thanks for that breakdown, DeWayne. Appreciate it. So what we'll do now, I think, is, maybe get into a little bit about the use cases that ONAP has brought forth already. Two of the, flagship use cases are the VOLTE use case and the VCPE use case. So I'll bring Eden here in to start us off. Why don't you go ahead and give us a rundown of sort of how the different use cases were decided, and how they started, how they were built, and what you guys did, what your involvement was in the use cases.
Yeah, sure. So, from the first day of ONAP, after we at least agreed on what will be the target architecture of ONAP after the merge between OpenO and eComp, OpenEComp, we set as a goal in ONAP to to be very fast, very quick with what ONAP can do, right? We are not a standard body as Amir mentioned. We are a reference implementation, so we need, to get some results down. And one of the things was to start in introducing new use cases. So it was decided to promote 2 use cases and approve them in the TSC forum as use cases for the Amsterdam release, release number A, the first one, and it was the VCPE use case. The VCPE use case was a use case developed, or at least proposed by AT&T and by Amdocs and other important members in the community. And the VoLTE use case, the voice over LTE use case, came from China Mobile and China Telecom, and mostly from the interest of the Chinese members coming from OpenO community. It was very challenging to take 2 kind of use case, totally different. One is 4G kind of a use case. Another one is a businesses deployment kind of a use case inside a VCPE, and to make them work on the same reference architecture. We just managed to stitch in a way and to make this available. And I think this is the power of ONAP in this way. How we can make things in, I would say, standard and abstract enough for many use cases to work on the same platform, run by an automation, design in a way that like you're designing Legos or building blocks, not doing anything with snowflakes, not doing anything very unique and tailored to the use case itself. And we managed to pull it off in Amsterdam release. Roy, maybe you can describe what is the VCP use case, what is it about, who is going to use it, and why.
Okay, sure. Thank you, Eden. Well, VCP stands for Virtual Customer Premises Equipment. Well, traditionally, communication service providers have always provided home customers with services through what's called a residential gateway device. That's an actual physical device that is located in the home and gives all the services, be that voice or data, to the customer. The disadvantages of having all that in a physical box is that if you want to introduce new services, then you usually have to replace the hardware, or it could take a lot of time. So nowadays that there are a lot of new emerging services such as smart home and home security and augmented reality applications, well, that having a physical box that's not agile enough to change with the requirements is just something you can't live with these days. So the solution for that is to split it into, you still need some sort of hardware at the customer site, right? So the solution is to split it into 2 separate components. One's called a Bridge Residential Gateway, a BRG, which is a simple box at the customer home. Mostly what it does, it just connects through a logical subscriber link to the second component, which is called the Virtual Gateway, okay, or VG. Now the VG is where all the smart things happen. It hosts all the network functions and all the services for the customer. So each customer has one physical BRG at his home, and he would have a corresponding VG, which is hosted on an edge cloud at the provider's cloud. Okay, and through that, the VG is, of course, as its name suggests, is virtual. So doing that, you can have a machine that you can manage and upgrade and change and add services to all the time without having to upgrade any hardware, sorry. Okay, so that means no technicians have to come to the customer's house. A much easier process, and it streamlines the process of adding new services from months to 2 minutes potentially. Okay, now in ONAP what we did is we modeled this use case, the VCP use case, into 6 services. Some of them are shared infrastructure services, and the BRG and the VG are per customer services. Okay, now in a nutshell, what this use case does is it allows service providers to provide more agile services to home customers to be able to upgrade or add value services. That can add, VPNs, they can add firewalls, they can add antivirus software, web filtering, parental control, all sorts of added value services that just wouldn't have been possible to add without upgrading a physical device in the traditional sort of solution.
Great, thanks for that. And so you guys want to also go into a little bit about the Volti use case as well?
I think we'll focus on the VCP use case. Maybe we can drill a bit about, because I think one of the things we can discuss together is the modeling of it, and I think the modeling of it is kind of neat and important to discuss. So maybe we can share a bit about how the model looks like.
Definitely.
Okay. So obviously we cut a lot of things here, and so the modeling of the VCP use case is kind of interesting, because we have VNFs and we have services that are infrastructure services. For example, a VDNS. A VDNS is something that I probably deploy once per site in any kind of an architecture, and then when I have a customer that needs to get a DNS services or virtual DNS services, he needs in a way to use it, right? I would not deploy a VDNS for every specific customer. This won't work. So we immediately saw that for this use case and for other use cases that we already solved in many ways, is that we need to differentiate between services that we call infrastructure services and other services which are the customer services. And in a way, we need to emphasize the ability in the model for a customer service to use, I would say, a slice, okay, let's do it free away, a slice of an infrastructure service. And a slice, it's a concept that it's abstract enough to say, I need a DNS services, I need maybe a DHCP services, maybe I need both, maybe I need a quality of service from an infrastructure service, some kind of precedence to my traffic, maybe I need an IP address of it. So I need something from the infrastructure service that it can provide to me in order to complete the customer service or the orderable service that I need to now orchestrate. So immediately we differentiate between the two, the infrastructure and the customer service. And we needed to make a way to model this kind of slice. So we introduced in ONAP the concept of allotted resources. Allotted resources are kind of a model that can explain or at least emphasize a slice of what we need. And in this particular example, we have an allotted resource that is a tunnel cross-connect in order to create a very specific cross-connect for the VPN that is part of the customer service itself. And we use this allotted resource as a node type in Tosca. So it can be part of the orderable, the customer service template, and the orchestration knows when orchestration function knows when it sees the allotted resource in the template, what exactly it should perform. So this was our way of introducing this a new modeling concept in ONAP in R1.
I think that's super important details and information. I think it's pretty noted by the industry, and those use cases, specifically VCPE, Volti, and coming to the next release with some new use cases, are really making an impact on the way that the customers are seeing ONAP and understanding the impact of ONAP in their production network, in their ability to modernize the data center and move from a legacy network environment, which those solutions were prescribed mainly by hardware and integration as legacy network devices, and now into a much more dynamic and scaling driven by software automation platform. So I think it's important to just I want to kind of re-emphasize some of those areas that impact. We see that impact on our customers that coming to us, and understanding that we can deliver. So if you look at Cloudify is a fully featured orchestration platform that can deliver automation end to end. But the point where Cloudify as a plug, as a technology that can enable a lot of technologies beneath it, there is a need for modeling, for example, and the Tosca as a key area that enable the modeling structure and language to enable real free or pure ability to interoperate between different companies and to deliver those NFV solutions, not as a cookie cutter vertical integration that one company can do, but rather as an open environment of innovation that each company can contribute its own innovation. We as Cloudify, we provide orchestration. There is a lot of innovation that happens in the VNF level, virtual network functions. There is a lot of innovation that happens at the SDN layer. And I don't think we mentioned enough the fact that ONAP is looks beyond the orchestration of just the virtual devices. It's an overall automation platform for a service provider to deliver end-to-end services. So I think we see it from the Cloudify side as something that drives the ability for customers to embrace those technologies and to have a little bit better understanding of how this technology is actually unlocks them and provide them future opportunities to integrate more innovation and to avoid the old lock-in mechanism in which company can only guarantee integration between its own components. And nowadays, when 100% of the service providers that we talk to are really embracing the standardization effort that ONAP bring. So I think we've seen before innovation coming from companies. We also seen there is other groups that were pretty active in trying to formalize the ETSI standards and make those long list of requirements and open source code, which is a valid approach. But I think the ONAP approach that's driven by the use cases and driven by a large community of committers and contributors, of member companies and individual, can create a very quick pace innovation that brings a much needed integration between those different software component, or mainly software driven component. I think one of those companies that is embracing ONAP technology is the one company that contributes probably the most to ONAP. So maybe my colleagues from AT&T can tell more about how the ONAP software is impacting the way that they are embracing software-based technologies in their network.
Yeah, sure. So,
okay.
So we develop Ecom from, I would say, the early days of 2014. As a prototype, we released a white paper, a well-known white paper about Ecom and what is Ecom mission, what are we trying to achieve. And I think AT&T management saw immediately a drastic change in the industry only because of the white paper and AT&T willingness to reconsider most of its OSS layer. AT&T even today has many OSS systems that are running in the network in order to introduce new services, orchestrate new services, govern the network, do any kind of configuration and alarm collection and so on, which is, it's ridiculous. Why won't we come to any kind of standardization around this area and try and streamline services as much as we can to run innovation on AT&T network and open AT&T network in a way that AT&T can provide to its customers benefits in days and not in years to deploy new service. So it really is about how we can streamline new services. And obviously the byproduct of it is when we talk about open source, and AT&T contribute, I think, 80% of the early code of ONAP itself is also to open the lock-in with the vendors themselves, because AT&T network is and was built based on a lot of vendors, and the knowledge is on their side. And it's also a real benefit to AT&T. And if we are able, and I think we are, is to make 80% of the use cases, like the majority of them, generic enough, AT&T can do a lot of automation, which reduces a lot of cost. And obviously, it's become less error-prone and much more effective. So AT&T set a goal, I think in 2012, to virtualize most of its network, like 90 or even 100% of the network. And AT&T, I think, said by the end of 2017, just a few months back, that AT&T virtualized 55 and above % of the network. So we are working towards a full virtualization, which will be a great achievement to AT&T. So it's it's all about making things much faster, much accurate, and to unlock automation as much as we can. Amir, I have a question. You mentioned the old days of, and even today, the standard bodies like IEEE and MEF, and we know that MEF is now part of ONAP as well. How do you see the maybe a good cooperation between a standard body like IEEE and MEF and maybe Tosca standards like ETSI and with an ONAP kind of all open source reference architectural development cycle? Do you see any way that we can interact between the two methods in order to make things better?
Yeah, I think you see that. So first of all, on the kind of the logistical note is that ONAP did form an official liaison with IETF, with ETSI, with MEF and TM Forum, and within those different standard bodies, they look at ONAP as an early adopter and early provider of the standardization information. So the whole cycle of standardization has changed from Let's sit in the room for 10 years or more, figure out the standard, then go and build the hardware and software that articulates it to a world where we as ONAP look at the use cases of what the industry needs, think through and work on a working code that articulates what the actual users need. And we do work with the standard bodies to make sure that the de facto code is not siloed and it is designed to answer a broader interoperability and view. So we've had those discussions within the modeling group within ONAP, and we as a member company is also in Tosca. I can tell you that most of the discussions in Tosca about the NFV profile and the progression of standardizing the Tosca portion is focused on the use cases and the examples that brought forward by ONAP. So there's already an effective cycle between the standard bodies where they contribute, and the same people that contribute the standards are contributing a code, and we are documenting the code and going back and working and making sure that the standards evolve together with the code. And the notable difference is MEF, which is not the traditional standard body, but there was an announcement of their lifecycle management use cases and the way that those use cases are now integrated within ONAP and with a view of ONAP as the technical articulation of the MEF lifecycle orchestration. So there is definitely a lot of joint work being done there. Maybe DeWayne, if you can cover from your side, because you've probably been heavily involved here in the way that modeling is actually delivering an actual through an actual orchestration and automation through your integration of Tosca into the SO. Can you speak a little bit about some of the differences in the automation approach between the workflows that were more structured around and the way that we see workflow automation in the future for ONAP?
Yeah, sure. This discussion typically boils down to the imperative versus declarative juxtaposition, if you will. The difference in approach from having a goal-driven system or a model-driven system, in the Tosca sense, versus something that's completely imperative. So in some ways, it's a false choice. You could view the model, a Tosca model, as simply a goal state for the network or service that you're trying to deploy. And the actual workflows are hidden in are completely generic and hidden inside the actual Tosca orchestrator. But these kinds of constructs are really, it's not an all or nothing situation. For example, as I mentioned earlier, in the SO, because of the organization of ONAP itself, the model may actually be multiple models. We talked about VNF infrastructure level. There's the VNF itself, which could be separate from that in the Tosca template sense. And then there's also services above that that can be modeled in Tosca, which may be treating VNF models as black boxes, essentially. All right. So a lot of how this is going to play out is it's still to be written. I think we see as Cloudify sees the Tosca sense of a topographic style model of the deployed network, which represents a goal state. This is really going to be the only way that that future automation, higher level automation, say involving machine learning, will actually be able to be done, because there has to be an explicit goal state. You can't just have a collection of bespoke workflows for each use case. You need a model that's somewhat constrained, or a collection of models that can actually be treated as a goal for the system, so the system can auto heal without specifically having code written, because the end state is already baked into the model. The goal is known, and if you modify the model, you modify the real world, and back and forth it goes. This is a similar to the approach taken, for example, by Kubernetes itself, which of course is being adopted widely infrastructure-wise in ONAP. But it's a similar type of concept, that the configuration represents, or the model represents, the goal state of the system.
Right. I think this is a great discussion, and we are, I think, in the SDC community working with Tosca in the past 3 years. I really lean towards a full declarative model, but we do at least can admit that some of the I would say ops use case, operation use case, mainly around the day one of a service lifecycle, like the change management kind of activity, at least some of them will probably stay as imperative task-based orchestration, because I'm not sure you are able to really code or declare the end state of what you are looking for. But I think it's not a 50-50 kind of orchestration methodology. It would be it should lean towards declarative or full declarative, like 80-20%, with some imperative capabilities for change management.
Yeah, I would agree with that. I think you're facing the same kinds of things when you talk about going from maybe the early auto industry, where everything is custom built, to something that's mass produced. And there are certain things that were given up by moving to a mass production model, but they were quickly swept aside because of the advantages of standardization and orchestration. But I would say that Tosca does have built into it a pretty liberal. We do think of day one, instantiation as being the be all and end all of Tosca, but it really isn't. There is a facility for adding custom workflows that can operate on the model in arbitrary ways, in ways that Michael was describing. So I guess
one question that
summarize, I wouldn't say purity is not a good approach in general. I think we have to be somewhat flexible when meeting reality, with some of these concepts, and see where it leads us. But the value of having a defined goal state for the overall system, I think, is essential.
Wow. Okay, guys. So thank you all for so far this really great discussion. We're just gonna wrap things up here. So do any of you guys have any sort of last things you want to get in? Anything that might you might want to mention about what you see going forward with ONAP?
Yeah, so I think now for the audience, we are in Beijing release, the second release, and it's really focused on hardening hardening ONAP, of course, making it much more easier to deploy, to operate, to have a service on it. And in parallel, there is a lot of discussions and a great work on how we can come with a unified information model and later on with a unified data model, at least for the SDC part, fully based on Tosca as it is today. I think it's going to progress us forward. It's not concluded yet. We are in the detailed discussions and the discussions and the implementation itself of the alignment of the model will come in the third release in Casablanca with more use cases up ahead. So I think one of the challenges for ONAP is to at least to stay very, very focused around use cases, to try to make the architecture work. It means that we need to keep the architecture not as liberal as other open source projects, to keep the components intact, to make the right borders between the components and the right interfaces. I think that the model is centric. If we can pull a unified modeling, we have all the building blocks we need in order to do automation. And with that, it will be much easier to provide all the use cases ahead and make ONAP a success. I think this is the goal, and I hope other community members are aligned with those goals.
I fully agree with that, and moreover, we've seen that one of the major events that happened very recently is an open source community. ONAP is now integrated together with some very distinguished other open source projects like Open Daylight, FDIO, and OPNFV. We are all together now in a single, we call it an umbrella project called the Linux Foundation Network. And I think what Linux Foundation Network brings is the ability to work across the project chasms as we deliver software open source to the masses. So we already had a lot of collaboration between the projects, but now we have a shared advisory committee, a shared board, a shared budget, and those and this should bring the collaboration even further, delivering the next generation use cases and simplifying some of those tough decisions that need to happen. And I'm very optimistic, looking forward, and judging from how much we have gone so far, looking at Beijing coming out of town, and also very soon we'll start planning and discussing the use cases for the next release. So this is very exciting times in open source and with the NFV industry as a whole.
Yeah, really great stuff, everybody. I think we covered a lot of ground in this podcast. Higher level, understanding strategically where ONAP is at, talking in detail about the architecture and how ONAP was built. So I really want to thank every one of you, Amir, DeWayne, Eden, Michael, Roy. Thank you all very much for your time. And until next time, we'll see you. Thank you very much. Really appreciate it.